Welcome everyone to lecture series of name reaction. I am Sagar Tanpure from Department of Chemistry, Sadguru Gadge Maharaj College, Kerala. So I teach you first name reaction, Diels-Alder reaction. Content, introduction, reaction, mechanism, stereo, selectivity. First part, introduction. What is the Diels-Alder reaction? The reaction between conjugated diene and alkene to produce cyclohexene compound is called as Diels-Alder reaction. This reaction used for synthesis of six-member ring. General reaction cyclo 1,3-butadiene plus ethene to form cyclohexene. See that here in this reaction formation of new pi bond and formation of new sigma bond here and here. Scientist Otto Diels and his student Kurt Alder were awarded the Nobel Prize in Chemistry in 1950. He discovered the name reaction and known as this reaction Diels-Alder. The reaction. This reaction is one step and concerted reaction. Concerted means formation of new bond and breaking of bond, that is concerted. Then second point is this reaction is 4 pi plus 2 pi cycloaddition reaction. The reaction between conjugated diene and substituted alkene, that is dienophine, to form cyclohexene ring system. Reaction undergoes via suprafacial interaction. Then mechanism. Conjugated diene react with double bonded dienophine. Diene react with dienophine. See here, diene having 4 pi electron, here 2 and here 2, that is 4 pi electron, here 4 pi electron, and dienophine having 2 pi electron. They both are react concerted mechanism, then form cyclohexene. Another mechanism, 4 pi electron react with 2 pi electron. Diene having 4 pi electron, dienophine having 2 pi electron. Diene are electron rich system and dienophine having electron deficient system. Both are react concerted then to form transition state. Transition state having 6 pi electrons, here 4 plus 2. Then formation of product having new bond, new pi bond, 1 pi bond and new 2 sigma bonds. Cis form is more reactive than trans form. Trans form is more stable, but cis form is more reactive. Dienophine and dienes. Firstly, dienes. It must be conjugated dienes and capable of existing in cis form. It contributes 4 pi electron. It is a electron rich. Substituted dienes carrying electron releasing substrate undergoes Diels-Alder reaction much more easily than dienophines. It is name given to the alkene component of this reaction. It can be simple or substituted acyclic or cyclic alkene. The dienophine carries electron withdrawing substituent. Here carbonyl, cyanide, both are ester group. Okay. It contributes the reaction 2 pi electrons.
This is the story of little Diane. Two double bonds, a single between. Unsaturated, conjugated alkene. My little S is Diane. Pi bonds, resonating energy. Delocalized electron density. Especially when she's high on EDG. My little S is dying. She's hot, hot, hot for lonely Mr. Alkene. With wide open arms, makes cyclohexane. With 2 new sigma bonds, where none had been. My little S is dying. She's slobbering around the electron poor part of town. She cycles for miles and miles. She needs a guy to make her smile, to love her in style, Mr. Dienophile. Singleness attitude, they call it single bond cis. Mr. Dienophile, add some heat to the mix. Gotta get that ring, 4 plus 2 make 6. My little S is dying. Me, lonely Mr. Alkine. Come on, baby, we can make something fine. Cyclohexadiene, the one for a kind. My little S is dying.
Oh well, my biggest sis, this is the story of O, 'cause she's a cyclic diene in funky, funky stereo, bicyclic adduct. Only one way to go, Mr. D must go down. ENDO.
Oh, this is the story of little Diane. Unsaturated conjugate.
Fourth point is stereo selectivity. Diels-Alder reaction is stereo specific with respect to both the diene and dienophine. See here, diene react with dienophine. Dienophine having cis geometry. Reaction occur then to form the product cis form. And another example here is trans geometry of dienophine, and product geometry is trans, that is stereospecific. See here, cis molecule dienophine, product geometry is cis. Trans dienophine, product geometry is trans. That is, addition is seen on the both the component. Then application. First, synthesis of quinone. 1,3-butadiene react with quinone to form this intermediate, and this intermediate used for the synthesis of quinone. Second application, synthesis of alpha terpineol. Isoprene react with methyl vinyl ketone, then to form this intermediate, and this intermediate is used in the synthesis of alpha terpineol. Third application, synthesis of camphene. Cyclopentadiene react with vinyl aldehyde. 4 plus 2 cycloaddition reaction, then formation of this intermediate, and formation of this intermediate then to use the camphene. And fourth application is synthesis of canthridine. Furane react with acetylene dicarboxylate to form this intermediate, and this is intermediate is very important for the synthesis of cantharidin. Thank you.